Hello, everyone. We are back again to our math journey. And in this journey, our goal is to make math easy and more comfortable. Yes, that's the goal. If you haven't yet subscribed to our channel, which is Tutoring Made Easy, I'd like you to do us this favor. Kindly subscribe, kindly like and share this video to as many people as possible. All right, we are going to move on with the topic set properties. Set properties. And I'm anticipating that this is going to be our first video on set properties. Now, there are three properties of sets. The first one is what we call the commutative. The commutative property. The commutative property. And the next one, the next property is known as the associative property. Associative property. And then the last one is known as the distributive. The distributive property. The distributive property. All right. So we're going to take them one after the other, one by one. And if we look at that, if we look at the commutative property, it says that if you have, let's say, for example, if you have, let's say, A union B, the property says that it's equivalent. It's equivalent to the same as B union A. So no matter how you look at it, even if you flip it on both sides, you're going to get the same result. A union B is the same as B union A. Joining A and B is the same as joining B and A. Now, on the flip side, if you want to find intersection between A and B, A intersection B, the commutative properties also says the commutative property also says that it is equivalent to finding the intersection between B and A. So regardless of how you want to flip it, the commutative property says it's going to be the same. So A union B is equivalent to B union A, and also A intersection B is also equivalent to B intersection A. I hope this helps. I hope this helps. Now, with associative property, we have two things there. The first one, uh, the first one, the first one says if you have A, it says if you have union, the intersection between B, no, sorry, if you have A union, the union between B and C, if you have A union B union C, or A union, the union of B and C, it says that it is equivalent. It is equivalent to the union of A and B, the union of A and B, that union, the union of A and B, that union C. So you can see it's like kind of expanded. This and that is in one parenthesis, and then you also have this and that in a sorry, I'll give you an example. Sorry about that. So it's like having this and that in one parenthesis and then just maintaining the union C. There you go. Now the next one, still an associative property, it says that if you have A intersection, the intersection between B and C, it says that it is equivalent to A intersection B, and intersection C. So the intersection between A and B, intersection C, is equivalent to A intersection, the intersection between B and C. So let me take it that again. A intersection, the intersection between B and C. It's equivalent to the intersection between A and B, intersection C. So far, we've looked at the commutative property, and we've also looked at associative property. Now, I want to let us have a feel of how all these letters, work. So we're going to take, I think we should end here, and then when we come back, I will take examples. I'll give us examples of all a proof of how this work for both for both for both the commutative property and associative property, and maybe later we can focus on distributive property. I hope this helps. Join me again. I'll come to you another time. Take care and bye.